alternating, plug it in, and you get 2 pins up there.
Wait, then we would only have
I think I found that too. So from here
there's 10 up
to
there.
here,
Yeah.
technically we can just do that.
I know, that makes no
But
sense.
and then
Let's
or
just
we
leave
could
it
just go
now.
here, and then we have those 2 feet over here.
Okay, and then that would add, instead of 1 big step, it's 3 small steps?
Yeah.
That makes sense.
So we'd have to do the 3 small steps.
It's such a minor detail that I'm not really concerned with which way you do it, as long as you understand why it seems like you do.
Okay.
Okay guys, about 1 minute, and I need everyone's eyes up front.
Mine. Yeah, fine. Hey, we
Yes,
have
Richard.
9 steps.
And does that get you all the way there?
One,
So how, can you just stop there?
because it's kind of like, it looks like there's 2 different tracks. Yeah.
Okay, so zoom in on that, see what happens.
Is it going that way?
Zoom in too much.
Oh, so it goes that way.
Would that add a step?
Yeah.
Would that bring you to 10?
I think so.
That'd be fine.
Okay.
The way you did it though, in all honesty, is fine. I'm not worried about you guys being that precise about it. That's just kind of a little, I don't even know if that was on purpose on my part. So either way you do it, as long as you understand why it's either 8 or 10 steps, I'm okay with it.
Alright.
Okay. Or the way you did 9, where you just kind of said from there to there is one heading, and from there to there on is another, I'm okay with that.
Alright. Will we get marked down if it's not exactly? Okay.
No, we're more concerned with like process and how to do this than we are with the answers.
Alright, so we don't have to go back and do that?
No. The way you have, you said 9, the way you figured it out, as long as you have that written down, that's fine. Okay, guys! If everyone can go ahead and take a seat.
Okay.
Go ahead and take a seat or turn around to your computer. We're going to do a little bit of debriefing. Okay, can I see your eyes, everybody? Tyler? Okay. So, this is the beginning of our unit this week that is going to culminate in the quiz on Friday. So, we want to understand the very basics of what we're doing before we move into the more physicsy, engineering, mathy type stuff. So to start, what was it about our directions that were important? In your first question on this worksheet, what did you decide were important features of your instructions you provided to these poor individuals?
You want to say heading, you want to be very precise, and you just write it down. Don't make sure you just want to make it very assertive and just say
Okay.
heading 124.27.
And so heading is a very precise what? It's a way to say,
Go see
it's a measurement of
direction.
right? So we used heading as a way to tell direction. So things that we needed were direction. Woo! That's like the 5th pen I dropped today. Okay. Direction. What else was important? Josh?
Units.
Units are important too. Those are always going to be something we need whenever we do any physics, really, or math. What else? What was really important about the instructions? Distance. So they needed to not only know which direction to go, but how far to go. And now, what would this give us? If you have distance and direction, what term do we know that as? Displacement, right? That's one of the words we worked on in our last quiz. So displacement is something that has distance and direction. So here I'm just going to put displacement What is the kind of related unit to displacement but that doesn't have direction? Do that. Distance. So distance has only really distance. That's the only thing about it, right? It doesn't have direction. We don't care about direction. So the new thing we're going to talk about is really just a word that adds a definition. Vector. So the word and the whole unit we're doing this week is on vectors. And now all a vector is it's some kind of quantity. It could be displacement, it could be velocity, it could be a lot of things. But that it has two key characteristics. One is that it has a magnitude, how big it is. So in our case here, displacement is a vector because it has a magnitude, which in this case is direction, drawing that backwards, which in this case is distance, and it also has, it also has direction, which in this case is very literal. And so the basic thing is that a vector is something that has both magnitude and direction. So the alternative would be like distance here, which we don't care about direction. Anyone know what that's called? You may have heard it once before. No, there's actually a funky word. It's kind of like a non-vector. It's called a scalar. So a scalar is something that has only magnitude. So for example, when we're talking about speed, does direction matter? So would that be a vector or a scalar? That would be a scalar because direction doesn't matter. When we talked about velocity though, does direction matter? Yes. And so if direction matters, and obviously how big it is matters, what would velocity be? It would be a vector because it has both the magnitude, like 3 meters per second, and also a direction, like northwest. Okay? So that's the big thing we're taking away from this, is that a vector is magnitude and direction. Now, we're going to deal with how to draw vectors and how to manipulate vectors. Adrian, you can close your laptop. You don't need it for right now. Brendan, close your laptop. So, we're going to need to know how to represent them and how to draw them and how to add them. We're going to learn all that stuff. But first, let's think about a problem like you just did. Let's say we have some building here and some building here, and we're trying to get from that x to the other x. But, like the activity you just did, we only have one safe way we can go. So how many instructions would you have in this example? You'd have 2 instructions. You would have from here to here and from here to here. Each of those you would say what direction to go and how far to go. But if you wanted to just graphically represent that, do you think of an easy way that you could just graphically show an instruction that has both magnitude and direction?
The grass just
Position.
no, not position. Velocity.
Well, we could do a motion map if this was like a velocity problem. But thinking just very generally, if you were to like draw someone a map and you wanted to show them where to go on a map, how would you show them? With an arrow, right? So let's just draw some arrows on here. Let's say the first instruction is we want them to go a certain direction for a certain length. And then for this way, we want them to go that way. And so those arrows, how long they are, tells us magnitude. And which direction they're going tells us direction. So right there, we found a perfect way to represent a vector. So that's really it. The whole thing there is that what we want to walk away from today is that there's this thing called a vector. it is some kind of quantity that has a magnitude, like distance, and a direction, like heading, and that we draw them as arrows. That's the magical thing we're going to spend all week on. So, vectors themselves are not crazy challenging. It's just learning the conventions. It's learning, oh, how do we draw the arrows? Which direction means what? How do we know degrees? And we'll be learning that over this week. But before we move on to that point, how would we calculate the distance traveled here? Okay, so you add the lengths together. So the distance traveled here would be the length from there to the next turn, and from there to there added together. But then what about displacement? How would you do displacement on this? Okay? From which point to which point? From the beginning point to the end point. So if we draw vectors like arrows, and we just want to go from the beginning point to the end point, then we can just do an arrow from beginning to end. From beginning to end, and this guy is displacement. And does displacement have a magnitude? Does it have a distance? Yeah, it has like a magnitude of the displacement. Does it have a direction? It does. Okay? So that's vectors in a nutshell. Now before we leave, we only have a few minutes left, I want to show you a quick clip. And a lot of you may have seen this, and you probably heard a couple people in the theater laughing, like me, and everyone else is like, I don't know what's happening. Not from James Bond, maybe a cartoon version. So, we'll watch it twice just to commit it to memory.
Oh, I love this movie.
I always wanted to do.
Oh, hold on.
Can I sit here?
It's the wrong one. Hold on.
Give me the better angle.
Not Leia. It's so cute.
Did the characters not have enough depth for you, Rachel?
What if there was like boils on your body? And it just made you smarter?
Okay. Eyes up, everybody.
That's me, as I'm committing crimes with both direction and magnitude. Oh yeah!
So has anyone seen that movie?
Yes.
Anyone get that joke when they first did it? No. Everyone's like, what? It's not a sex joke.
I just think you look funny.
So, that character's name is Vector.